Good afternoon, everybody. My name is Mike Miklos. I am a residential carpenter out of Local 723, and this morning we are going to be learning how to cut a common rafter. A common rafter will typically look something like this. You're going to have a plumb cut, which is going to be your peak or your ridge. You'll have a bird's mouth, where this will sit on the wall, and you're gonna have an overhang. Typically an overhang is 1 foot, but for this demonstration, I made a 6-inch overhang. To begin the lesson, we need to learn a couple of things. First off, tools. We all have tools, and we all need to carry them. The few tools we are going to need are going to be a pencil, a tape measure, a speed square, and a Construction Master Pro calculator. We are also going to need a circular saw, and a handsaw. This is a Japanese pull saw. It is designed to cut on the pull, not on the push, and is a nice flexible handsaw. It works very well for this application. Now, to begin, I'm going to start with your speed square. I'm going to give you a quick demonstration of the speed square, and I am going to explain a few things. A speed square is extremely important in the field. It allows you to make a 90-degree angle instantly. That is why they call it a speed square, because you can make a square line with a lot of speed. On this speed square, we have a tape measure. Goes up to 7 inches with a diamond at the 3.5 inches, which is the same thickness of a 2x4, to allow you to scribe mark anything you need to at least at 3.5 inches. It also has this nice degree finder. It goes from 0 to 90. Then it has a table for a common rafter, which goes from a 1-inch pitch all the way up to a 30-inch pitch. Then it has another spot, where it says top cut is a hip and valley. It'll allow you to do the same pitch from 1 pitch all the way up to a 30 pitch. It'll allow you to hook on anything, and you can use this as the most versatile layout tool in the business. After that, you have your Construction Master Pro. And on your Construction Master Pro, this is just like a typical calculator, except this allows you to use feet, inches, and meters and convert everything. Kilos, pounds, yards, meters, feet, everything. Also, the greatest thing about this calculator is the math. When calculating a rafter, you use the Pythagorean theorem, a squared plus b squared equals c squared. And the easiest way to do that on this calculator is to input a run, then input a rise, and then hit diagonal. And when you hit that diagonal, it will give you the length of C, which just happens to be a hypotenuse. So it'll give you a hypotenuse of your A and your B of your angle. Also, with this square, with this calculator, what it can do is calculate stairs, rafters, arcs, circles. It can give you the area of stuff in case you have to find the area of something. Well, now that I gave you a quick understanding of this, what I'm going to do is tell you how this calculator will allow you to complete the cut and layout of a rafter. What you need to do is you need to figure out the span. The span of your building is the distance between here and here. This is simulating a top plate, and this is a rafter. Now what you need to do is to find out your span. Once you figure out your span, the width of your building, you're gonna go ahead and divide that by 2, because in a roof, you have 2 rafters. In this scenario, we are not installing a ridge. If we were, we would have to reduce the size of the ridge from the length of the rafter as well. So what I did was a nice little 4-foot span so it can sit on a sheet of plywood. So what you need to do is take your calculator. You're gonna hit 4 feet, run, then our pitch. And in this scenario, our pitch is gonna be a 6-12 pitch. And what that means is for every 6 inches of run, it's going to rise. I'm sorry, every 12 inches of run, it's going to rise 6 inches. So I'm going to 4-foot run, 6-inch pitch, diagonal. That is the whole entire building. Remember, we did not calculate for half. So we're gonna go 2 feet, run, 6-inch pitch, diagonal. And when we hit the diagonal, we're going to come up with 2 foot 2 and 13/16. That is the length of your rafter from the peak all the way down to the edge of building. So this rafter from here to here, as long as you run this line straight up, in line with it, on a 6-degree pitch, that will be 2 foot 2 and 13/16. Then you need to calculate your 6-inch overhang. And to do that, you can write down your number, 2 foot 2 and 13/16, right? 2, 13/16. Now, I'm gonna clear it out by hitting the red button. I'm gonna hit 6-inch run, 6-inch pitch, diagonal. And that's gonna give me 6 and 11/16 of an inch. And then I'm going to add the length of my rafter to the edge of the building. So 2 feet, 2-inch, 13/16 run. I apologize, you're not gonna do the run, you're just gonna add. So you're gonna add 2 foot 2-inch 13/16 plus 6-inch 11/16 equals 2 foot 9.5. Now, what that means is I need to take my tape measure and hook the top at the peak, come down 2 foot 9.5 inches, and that'll be right there. I will make a mark, and then I will go with a 6-inch pitch. This plumb cut, and this plumb cut are all on 6-inch pitches. So from this point to this point is gonna be 2 foot 3 and 13/16. But I'm gonna make that mark and run it down on a blank piece of wood, and that'll give me this line. I also need to put on my overhang, which is 6 inches, right? And that, from this point to the edge, is 6 and 11/16. And overall, this whole entire length will be 2 foot 9.5 inches. And that is how you will calculate the length of this. Now, after you calculate the length, you're gonna have your edge of building and you're gonna have your overhang. As you can see, I wrote EOB for edge of building. Your overhang we're gonna cut out this bird's mouth. And to cut out this bird's mouth, we need to know what the height above plate is. So, typically you will get that on a drawing or a plan from your structural engineer. And they will give you the information. In this scenario, we did a 4-inch height above plate. That means where right here, where the plate's gonna, where this wall's gonna, this rafter will sit on the wall plate, 4 inches is above the plate. So the distance between here and here is 4 inches. That will allow for 1.5 inches of height here and 3.5 inches here. That is the full height, a full thickness of a 2x4. A 2x4 will easily sit right in here. And this will sit right on top of your wall. Now, to calculate the bird's mouth, again, you're gonna come down from the top 4 inches and make a mark this way. Then you're going to take your square and you're going to put your square on your rafter and you're gonna flip it, right? So you're gonna put it in line with your line here, your edge of building line, and you already have your 4 inches of height above plate. That's gonna give you this. And all that really is 90 degrees off of the line for my edge of building. So it's very simple. All I have to take is my square, this little hook part, hook it on my line, like so. Make sure I'm plumb, and then I can calculate my bird's mouth. After you calculate, you need to cut it. And when you cut it, you need to make sure you don't overcut. You see on this side, I have overcut here and here, just so that it was speed. I'm only caring about speed on my template. This one right here would be a template or a pattern. We would take this and write big old on here, temp or pat, and this one would get set to the side, and I would use this one, and I would scribe this one and copy it on every one. And when I do that, then I will pull out my Japanese pull saw to make sure I don't get any overcuts, right? What we just learned. We learned about a framing square, a speed square, excuse me. It has a tape measure up to 7 inches. It has degrees, a common rafter, and a hip and valley rafter. That's what this square has. Then we have a calculator, and this calculator will eliminate the need for math for the Pythagorean theorem, the run, rise, diagonal. The diagonal gives you your hypotenuse, or the length of your rafter. You're gonna take your rafter, mark from your peak, down to your edge of building. That number is gonna be 2 foot 3 and 13/16. Then you're gonna do a 6-inch overhang. From this line to the edge is 6 inches and 11/16. This bird's mouth is cut because we have a 4-inch height above plate. And in line between here and here is 4 inches. And then off of this line, I'm gonna go 90 degrees, and that'll give me my bird's mouth. When we are cutting, you're gonna have gloves on. You're gonna have safety glasses on. And you're not gonna overcut, because if you overcut, it weakens that point of the rafter and makes it much less structural. Thank you very much for coming out to the class. I appreciate you. Have a great day.